Welcome everybody. So today we're going to talk a little bit about position, and to do that I have fired up a map of Oregon here, which is where I am. And in particular, I'm at Oregon State University, which is in Corvallis. So I'm going to go ahead and try to ask some questions like, where is Corvallis? What would the position of Corvallis be? So on my map, I'm going to go ahead and answer how you probably would answer this question at first glance if you had a map like this, which is to point at it or to draw on the map. Let's see if I can do this here. We're about right here. Right? So a perfectly satisfying answer in our everyday life for where is Corvallis would be to point at that dot and say, there it is. But in physics, what we're going to be doing is spending time quantifying things that we see all the time in our everyday lives. So what I'm going to do is try to figure out how I can tell someone where Corvallis is more formally and quantitatively. And to do that, I'm going to use the idea of a vector to describe position. And to do that, the first thing I'm going to need to establish is an origin. Now it turns out that you can pick any point you want as an origin. For simplicity's sake, I'm going to sort of go to the middle or so of Oregon, maybe somewhere right here. And I'm going to go ahead and say that this is my origin and draw a little dot here. You can put a little O if you want by your origin. And along with the origin, what I'd like to do is have a set of axes. So I'm going to go ahead and draw some axes in here. Draw a vertical axis, and I apologize if I'm not the best at drawing these things. And then we'll draw a horizontal axis here. And just like any axis that you might have seen in math, you probably would put some little arrows on here. We can go ahead and put arrows on all the different sides. And I probably want to label each of these axes. And I'm going to use the convention that you probably also used in your math class, which is to call the horizontal axis x and to call the vertical axis y. Once I have that chosen, I can now draw a vector or an arrow to represent the position of Corvallis given the origin that I have chosen. So I'm going to go ahead and do that. I start at the origin, and I draw a vector that points from the origin to Corvallis, like so. And I'll put the little arrow symbol on it so everybody knows that we have a vector quantity here. And there's all sorts of things that I can do with this now. One of them is I could start by labeling this. And we're going to use, for position, the symbol R to represent a position vector. You will sometimes see X as a position vector, but we're going to try to stick with R for most of the course. And so I'll go over here and I'll label this the position vector R. And in physics, we usually want to be more specific about the quantities we're dealing with. So this is not just any old position vector. This is the specific position vector for Corvallis. So I might decide to indicate that with a little subscript, here a C for Corvallis. And now I have a vector that indicates the position of the city. A natural question at this point might be to think about what would another position vector look like. So I can imagine Portland, which is the big city in Oregon, and I can go up here, and I think I'm pretty close on where these are, but it's always possible I could be a little bit off here. So there's Portland, and I could draw another second position vector, which again would start at the origin and would point in a straight line to the location of Portland, and I could label that R sub p for the position vector for Portland. And now I have two position vectors, and I could do this for any number of locations on my map.